There are many different types of shell and tube heat exchangers, and each one is designed to accomplish a specific function in a process. Condensers are one type of shell and tube heat exchanger. They're designed to convert gases or vapors into their liquid states. Here's an example of a typical condenser. It's used to turn steam into water so that the water can be reused in a steam generating system. Condensers can also be used to cool and condense product vapors. For example, the vapor produced in this distillation column flows into a condenser and is converted to a liquid. Depending on the process involved, the liquid formed in a condenser may be referred to by different names. The water that's formed when steam is condensed is called condensate. On the other hand, the liquid that's formed when product or byproduct vapors are condensed is often called distillate. To get a better understanding of how a condenser operates, let's look at an illustration of a condenser that uses cooling water to condense product vapors into distillate. This condenser has a shell, tubes, tube sheets, a vapor inlet, a cooling water inlet called a head, a distillate outlet, a cooling water outlet head, and a receiver. On this type of condenser, the cooling water heads may also be referred to as water boxes. During operation, on the tube side of the condenser, cooling water enters through the inlet head, passes through the tubes, and flows out of the condenser through the outlet head. On the shell side of the condenser, vapor passes through the inlet and flows around the tubes. When the vapor comes into contact with the cool surfaces of the tubes, heat is transferred from the vapor through the walls of the tubes to the cooling water. As heat is transferred to the cooling water, the vapor cools and condenses on the surfaces of the tubes. The condensed vapor, or distillate, drips off the tubes and falls to the bottom of the shell. It then flows through the distillate outlet and into the receiver. The receiver receives or collects the distillate that drains from the shell of the condenser. The distillate is usually sent on for further processing or to storage. Now, as the vapor condenses, a low pressure is created inside the condenser. This low pressure draws more vapor into the condenser. In order for vapor to continue to flow into the condenser, the pressure inside the condenser must be lower than the pressure of the vapor entering it. Condensers can be operated at almost any pressure, as long as it's below that of the entering vapor. For example, the vapor entering this condenser is at 250 psi, and the condenser is operating at a pressure slightly less than that. On the other hand, this condenser is operating under a vacuum, because the vapor entering it is near atmospheric pressure. In a condenser that operates under a vacuum, the condensing vapor normally maintains the vacuum. However, when the condenser is started up, auxiliary equipment, such as a steam jet air ejector, may be needed to establish the initial vacuum. A steam jet air ejector consists of a steam inlet, a nozzle, a suction port, and a combining tube. Normally, the combining tube is connected directly to a small condenser called an air ejector condenser. As the steam passes through the nozzle, it is accelerated. As the fast-moving steam leaves the nozzle, it draws air in from the main condenser through the suction port and to the combining tube, where the air mixes with the steam. This mixing process is referred to as entraining. As the steam and air mixture flows out of the air ejector, an area of low pressure forms in the air ejector suction port. This low pressure draws additional air in from the main condenser. This air also becomes entrained in the steam, and the process continues. The final result is that the pressure in the main condenser decreases. In some systems, the air ejector and its condenser are shut down after a vacuum has been established in the main condenser. But in some processes, the air ejectors remain in service to remove air and other gases that won't condense. You see, non-condensable gases can build up inside a condenser. When this happens, the gases insulate or blanket the tubes and reduce the amount of heat transferred in the condenser. As a result, less vapor will condense, and the pressure inside the condenser will increase. The increase in pressure may reduce the flow of vapor, or it could stop the flow altogether.